Welcome back to the Scotti-BYTE channel, and this is Scott. So Virtual Router Redundancy Protocol, often referred to as VRRP, is most commonly used for network gateway redundancy between multiple ISPs. It's also used for firewall failover and failover for key services. And I noticed here that on my Ubiquiti UDM Pro, they have a section under the control plane and the console settings to where they have the concept of a shadow gateway. And digging into that shadow gateway capability, I discovered that that's a case where they can have two like consoles, like two UDM Pros, and if one fails, then it can fail over to a second one. And that's a common use for VRRP. In this video, we're going to do something just a little bit different. I am going to show you how to use the VRRP protocol for automatic failover. And in fact, I use it for applications, and I've done two videos in the past, one entitled Automatic Failover, Nginx Proxy Manager and SEER XNG, and one entitled High Availability, Pi-hole, and Local DNS. Since I already have VRRP services defined on my network, I have a script that I've developed in order to see which services are available. And in that particular script, I'm going to edit a file called VRRP_scan.sh. And this is a bash script that I have developed, and I'm pasting the contents here, which will be in the show notes. And I'll go ahead and do a Control-O and Enter to save the file out, and a Control-X to exit the nano editor. Before you're able to execute a bash script, you have to provide it execute privilege, and we do that with chmod +X on the VRRP_scan.sh script. And now to execute our script, I simply do a /VRRP_scan.sh. This script requires a program called tshark. And so I'm going to install tshark with a sudo apt install tshark as the comment in my script indicates. I provide my sudo password, and I go ahead and say yes, install tshark. Now you get this prompt in the process of installing tshark, and I like to go ahead and say yes, you can allow non-super users can do this. It's up to you. If you say no, then you'll have to do sudo in order to run the script. With tshark installed, I can go ahead and execute the script now, and it will find out what my default route is and use that device, in this case bridge 0, to scan my network. And it's scanning for VRRP master advertisements. And so we have, first of all, a virtual router ID number, and that's an arbitrary number that you create for each of the services. And then secondly, we have the host, and then we have the master IP, which is the IP of the particular container or host providing that service. And then we have a virtual ID that is associated with that. To understand the application for VRRP, I'll simply define my virtual router ID of 6 is serving my Nginx Proxy Manager service. And my primary Nginx Proxy Manager is operating at 172.16.1.215. However, I have a backup Nginx Proxy Manager that's running at a different address. However, this master is now offered at 172.16.0.15. If the primary Nginx proxy manager here goes down, then a backup of Nginx proxy manager comes up, and it will be offered at the address of 172.16.0.15. Likewise, with Pi-hole, I actually have 3 Pi-holes offering my local DNS. One is on my host called VMS Mist, another is on my host named VMS Rain, and the last is running on a Pi 4. This primary one is running at 172.16.1.6 right now, and its virtual IP is 172.16.0.10. If the primary went down, the secondary would take over. That runs at 172.16.2.1, but we really don't care about that since it's going to be assuming this address of 172.16.0.10. And this is what allows you to run services that run even though one particular system may be down. And in my final example here, I'm running Seer XNG, which is a custom privacy respecting search engine, and it runs its primary at this particular address, but we really don't care about that because its virtual IP is 172.16.0.30, and if the primary Seer XNG goes down, the backup will come and take over the address of 172.16.0.30. Let's go ahead and create a simple example of setting up a VRRP configuration. In order to do so, I'm going to launch an Incus container and create a container called test1. And test1 will have an address on my mainland in virtue of the bridge profile. Secondly, I'm going to go ahead and create a second container called test2, and likewise, I'll go ahead and create a third container named test3. Now that all 3 containers have been created, I'll go ahead and do an Incus list, and we can see that test1, test2, and test3 all have addresses on my main LAN, which is at 172.16.1.whatever. Let's connect to the shell on the first container with an Incus shell to test1. The first thing you should do whenever you're entering a new container is to take all of the updates for it. And we do that with an apt update & apt upgrade -y. Let's install some dependencies in the new container, and we're going to install net-tools, OpenSSH server, the Nano editor, rsync so that we can copy things from one container to another if so desired, and keep alive D, which is actually the VRRP daemon on Debian machines. Now that all the dependencies are installed, in particular keep alive D, let's go ahead and edit the configuration file for keep alive D, which is in /etc/keepaliveD/keepaliveD.conf. The first system that you configure with VRRP is referred to as the VRRP master, and so I'm going to paste in the code into this configuration file. You see here at the top that it says that our VRRP instance is going to be called test. That's just what I decided to name it. The state is master, which means it is the first node, as I mentioned here. Our interface is ETH0 because ETH0 is the name of the network interface inside of an Incus container. And I've given it the virtual router ID of 5. Each application needs to have a unique virtual router ID, and So you can have 3 or 4 machines or more that would operate inside of a particular VRRP instance. They would all have the same virtual router IDs. The master, by definition, is provided priority 255, and then each of the backups are given a lower priority. And then the advertising interval I set up to be 1 second so that it can be discovered quickly on the network. We have an authentication section which indicates a password, and that's just for security purposes. And then we need a unique VRRP address. In my case, I'm adding an address that is available on my network that nothing else is using. So I'm using 172.16.0.55. Now I do a Control O and Enter to write the file out, and a Control X to exit the nano editor. In order to activate our VRRP configuration, I will have to do a sudo systemctl restart keep alive D. For the purposes of this demonstration, I'm also going to do a add user Scott, and I'll give Scott a password. And then I will go ahead and do a usermod -a G sudo Scott, putting Scott into the sudo group. Now I'm going to go ahead and exit out of the test1 container. And now I will go ahead and SSH over to, or Inca shell over to test2. And likewise on test2, I'm going to go ahead and do an apt update & apt upgrade -y, just to take all the upgrades to the repository and any code that needs to be upgraded. And it looks like I forgot to put a space there, so let's try that once again. Just like last time, I'm going to edit the keep alive D configuration file with a sudo nano /etc/keepaliveD/keepaliveD.conf. This time the configuration file looks a tad bit different. Mainly its state is backup. We have one master, and then we have as many backups as we want. Again, because this is a container, the interface is named ETH0. We're using the same virtual router ID of 5. This time the priority is 254 because the master started at 255. We have the same advertising interval, we have the same password, and we have the same virtual IP address. Let's do a Control O and Enter to save that file out, and a Control X to exit the nano editor. To have our new configuration take effect, let's do a sudo systemctl restart keep alive D. Let's also add a new user account over here with an add user on Scott. Go ahead and give Scott a password, and go ahead and do a usermod -a G sudo Scott, putting Scott into the sudo group on this machine as well. Now let's go ahead and exit the test2 container, and let's do an Inca shell over to the test3 container. On the test3 container, we'll go ahead and take the same updates. Now that the container's up to date, we'll go ahead and install the same dependencies. Let's go ahead and edit the keep alive D configuration file. Let's paste the VRRP configuration into this file. Again, the instance name is going to be test. The state will still be backup. The interface will still be ETH0. the router ID will still be 5, but this time we'll change the priority of this backup container to be 253, and then everything else remains the same. Let's do a Control O and enter to write the file out, and a Control X to exit the Nano editor. Let's restart Keep Alive D to have our new configuration take effect. Let's go ahead and add a new user with an add user Scott. Give Scott a password. And then we'll go ahead and put Scott into the sudo group with the usermod -a capital G sudo Scott. Let's exit out of the test3 container, and let's do an incus list. And just as a reminder, test1 has the first container, and it is at an address of 172.16.1.236, but I also want you to notice that it has a VRRP address of 172.16.0.55. Container test2 has a different address, and likewise test3 has a different address as well. Let's go ahead and do an SSH into 172.16.0.55, which is the VRRP address. I'll go ahead and say yes and type in my password. And then it logs into test1. Now let's go ahead and we exited out of the test1 container, and we knew it was test1 because it gave us the prompt of test1. Now let's go ahead and do an incus stop on test1. And once we do a stop on test1, if we do an incus or if we do an SSH over to the same 172.16.0.55, we get a error for our fingerprint because it has changed MAC addresses. So we'll go ahead and remove that, and then we'll go ahead and connect into it again. I'll say yes, and I'll type in my password. And instead of going to test1, this time we're on test2. If I exit out of this container and I do an incus list, you'll notice that test1 is stopped. It's the master. Test2, though, has taken over the address of 172.16.0.55. Likewise, if I do an incus stop on test2 and wait for it to stop, and then do an SSH to 172.16.0.55, again, it's telling us that its address has changed. So we'll go ahead and remove it from the SSH keygen, and now we'll do an SSH to 172.0 or 172.16.0.55. Once again, we'll say yes, we'll type in our password, and this time we're not on test2, we are on test3. Now if I exit test3 and I do an incus start on test1, and then I do an incus list, we'll see here that test1 is running. In a minute, it'll go ahead and get its password. I just want you to notice right now that test3 has the VRRP virtual address of 172.16.0.55. Now when I do an incus list again, since we've given plenty of time for test1 to start and readdress itself, it has come back online, and now test3 doesn't have the VRRP address. Test1 has the VRRP address. And so once again, if I SSH to 172.16.0.55, it's going to warn me again that host key has changed. So I'll go ahead and remove it from that list and then SSH in again, say yes, and I'll go ahead and type in my password. And now we're back at test 1 again. If I exit back out of here and I do a incus list, and then I do an incus start on test 2, test 2 will get its address again, but it won't take over because the master's up and running. So the master will continue to have the 172.16.0.55 address because it is the master. And we're still waiting for test 2 to come back up. And it takes just a little while to contact the DHCP server. And any minute now it should come back, and there it is. If you will recall the script that I created at the beginning of this tutorial, VRRP _scan, if we now run that particular script, and I guess it's going to ask me for my sudo password, it will come back and give me a listing of those nodes. And here you notice that we have VRID number 5, and it is operating at host 172.16.1.236. The reason it doesn't have a name like the rest of these is because I did not put a DNS name in my local DNS. So its master ID or master IP is the same as the host name in this particular case, but we now see that it is running at virtual IP 172.16.0.55, and its virtual router ID is 5. Recall that for each application, you must have a unique VRID and also a unique VRRP. Just as a quick example, I went ahead and took my 3 test nodes and put them in the local host table just so that they would be listed by a name. And now I'm going to go ahead and do an incus stop on test 1. And after doing a stop on test 1, I'll go back and do the VRRP scan once again. And VRID5 is now pointing to test 2 at the address of 172.16.151 and not test 1 at 172.16.1.236. And likewise, if I do an incus stop of test 2, now test 1 and test 2 are stopped. And so if I run the VRRP scan once again, VRID5 will now be pointing to test 3, and you see its address is 172.16.1.75. In all 3 of these switches, you notice that the VRRP virtual ID is the same at 172.16.0.55 in the first example, in the second example, and finally in the third example. VRRP has some really terrific application use cases, and in my video entitled Automatic Failover, Nginx Proxy Manager in SEER XNG, I show how you can use rsync in conjunction with VRRP to keep multiple instances of Nginx Proxy Manager and multiple instances of SEER XNG in sync with one another to support automatic failover. And then in my video entitled High Availability Pi-hole and Local DNS, I use Nebula Sync to synchronize multiple Pi-holes, and then I provide the VRRP virtual address as my DNS primary address for my DHCP server rather than the address of any particular single pie hole. VRRP is an awesome way to provide high availability services on your network. Anyway, that's it for today. Please subscribe and like to the channel, and don't forget to hit your notification bell, and we'll see you next time.